What did Bethlehem Steel build? The Golden Gate Bridge, the George Washington Bridge, the Ben Franklin Bridge, the Empire State Building, the Chrysler Building, Rockefeller Center, the Hoover Dam, Madison Square Garden, the United States Supreme Court Building, the prison on Alcatraz Island, the 110-foot lock gates of the Panama Canal, the 45-foot steel axle for the world's first Ferris wheel at the 1893 Chicago World's Fair. By 1940, 80% of the New York City skyline was constructed with structural steel rolled at the Bethlehem plant. 80%. 4 out of every 5 skyscrapers in Manhattan were standing on Bethlehem beams. And that was the civilian work. The military work was larger. Every armor plate on every United States Navy battleship from 1887 to 1945 was forged at the Bethlehem plant. Every heavy gun barrel, every warship hull plate. The company that started as a small iron, works on the Lehigh River in eastern Pennsylvania, became the second largest steel producer in the United States and the largest shipbuilding company in the world. During World War II, Bethlehem Steel's shipbuilding division produced 1,121 warships for the United States Navy, 1,121 ships. Eugene Grace, the company's chief executive, had promised President Franklin Roosevelt that Bethlehem would deliver a ship a day. Grace exceeded the promise. In 1943, the company delivered 380 ships in a single year. The plant in Bethlehem employed 31,523 people at its wartime peak. The campus sprawled across 1,000 acres of the Lehigh Valley. The blast furnaces ran 24 hours a day, 7 days a week, fed by ore trains and coke trains and limestone trains that arrived around the clock. They called Bethlehem Steel the arsenal of America, and the name was not an exaggeration, it was an understatement. The furnaces are still there. 5 blast furnaces, standing on the south bank of the Lehigh River in Bethlehem, Pennsylvania, rusted orange, a quarter-mile long and 230 feet tall at the highest point, with the ore bridges and the gas cleaning equipment and the hot blast stoves and the skip hoists and the charging floors still attached, open to the weather, visible from the highway, visible from the Fahey Bridge, visible from every angle of approach to the city. You can walk right up to them. You can walk along the Hoover Mason Trestle, an elevated pedestrian walkway built on the former ore conveyor line, 1,650 feet long, and look directly into the furnace structures from a height of 40 feet, close enough to see the refractory brick lining through the holes in the steel plate, close enough to see the piping and the valves and the tuyere openings where the preheated air was blasted into the furnace at 1,200 degrees. The trestle runs the entire length of the furnace complex. Interpretive plaques along the walkway describe what each structure did and who worked in it and what happened on the last day. The blast furnaces that armed 2 world wars and built the New York skyline are standing next to a casino and a concert venue. The Steel Stacks Arts and Entertainment District, which opened in stages beginning in 2011, occupies 10 acres of the former plant site. The Arts Quest Center, a 65,000 square foot performing arts building, sits at the base of the furnaces. The Levitt Pavilion, a free outdoor concert venue with lawn seating for 2,500, faces the furnace stacks directly. On summer evenings, concertgoers sit on the grass and listen to music with the 5 rusted blast furnaces rising behind the stage like the pipes of an enormous cathedral organ. The Wind Creek Bethlehem Casino Resort, formerly the Sands Casino, occupies another section of the former plant. The National Museum of Industrial History, which houses artifacts from the Bethlehem plant and from American industrial history more broadly, sits nearby. The furnaces are the backdrop. The entertainment is the foreground. The relationship between the two is the story. I went looking for the history of those furnaces. What I found was 138 years of continuous industrial operation, from the first blast furnace lit on January 4, 1863, to the last pour on November 18, 1995, encompassing every major military conflict and every major construction project in the country, built by a company that was founded during the Panic of 1857, nearly died before it started, and grew into a corporation whose executives held 7 of the 10 highest paid positions in the United States, while its steel workers worked 12-hour shifts on the furnace floor below them. And the furnaces that did all of this, the 5 blast furnaces that consumed iron ore from the Mesabi Range and coke from the Connellsville region and limestone from central Pennsylvania quarries, that converted those raw materials into the pig iron that fed the open hearth furnaces that rolled the beams and the plate and the armor that went into every structure and every warship on that list, are standing in the open air in Bethlehem, Pennsylvania, rusting, silent, their hearths cold for 31 years, beside an art center and a casino and a free outdoor concert venue where people sit on the grass on summer evenings and listen to music with the furnace stacks rising behind the stage. The origins of Bethlehem Steel trace to April 1857, when Augustus Wolfe founded the Salcona Iron Company in the Lehigh Valley to supply iron rails to Asa Packer's Lehigh Valley Railroad. The panic of 1857 immediately stalled the venture. When the economy recovered in 1859, the company was reorganized, moved to South Bethlehem, and renamed the Bethlehem Rolling Mill and Iron Company, later simplified to Bethlehem Iron Company. In 1860, the company hired John Fritz, one of the most respected iron makers in the country, to design and build its blast furnaces and rolling mills. Fritz had pioneered the three-high rail mill at Cambria Iron in Johnstown, Pennsylvania, and his reputation brought credibility to the young company. Construction of the first blast furnace began on July 1, 1861, 3 months after the Civil War started. The furnace was operational by January 4, 1863. The first railroad rails were rolled on September 26, 1863. A machine shop followed in 1865, a second blast furnace in 1867. Bethlehem Iron was in business. The company's early years were defined by railroad rails in the Civil War. But the product that would transform Bethlehem from a regional iron maker into a national institution was armor plate. In the early 1880s, the United States government decided to modernize its aging wooden-hulled Navy with steam-driven, steel-hulled warships. The Navy needed armor plate, heavy gun forgings, and large-caliber gun barrels, and it needed a domestic source that could produce them without relying on European manufacturers. On June 28, 1887, Bethlehem Iron secured the contracts to provide both forgings and armor plate for the Navy's two new second-class battleships, the USS Texas and the USS Maine, the ship whose mysterious explosion in Havana Harbor in 1898 would help trigger the Spanish-American War. Between 1888 and 1892, Bethlehem built the first heavy forging plant in the United States, designed by Fritz with assistance from Russell Davenport, who joined the company in 1888. The forging plant included a massive steam hydraulic forging press capable of producing the gun barrels and armor plate that no other American facility could manufacture. The 1,000-acre campus expanded with new munitions depots, machine shops, and blast furnaces to meet military demand. If the military history of American steel interests you, Bethlehem's wartime production records are among the most detailed in the industry. The contracts, the tonnages, the ship counts, the armor specifications are in the company archives and in the Navy Department records. Look at what the evidence shows, and subscribe if you want to see where the next thread leads. In 1901, Joseph Wharton, one of Bethlehem's principal stockholders, attempted to sell the company to a British armaments consortium. The deal fell through. Instead, Charles M. Schwab, who had been the first president of J.P. Morgan's United States Steel Corporation, and before that, the president of Carnegie Steel, acquired a controlling interest in Bethlehem in 1901 and took the helm in 1904. Schwab was 42 years old when he took over Bethlehem, and he had already been the operational head of the largest steel company on earth. He brought Carnegie's methods, Carnegie's ambition, and Carnegie's ruthlessness to the Lehigh Valley. Under Schwab's leadership, Bethlehem Steel became the second largest steel producer in the United States, behind only the United States Steel Corporation that Schwab himself had helped create. Schwab's most consequential innovation at Bethlehem was the wide flange structural beam, known as the H-beam. In 1907, Schwab built a new open-hearth steelmaking plant, and in 1908 commissioned a $4 million rolling mill specifically designed to produce structural beams with wide flanges up to 36 inches in height that were stronger and lighter than the standard I-beams that other steel companies produced. The H-beam was patented. Bethlehem commanded premium prices for it, and the H-beam made modern skyscrapers possible. The wide flanges distributed structural loads more efficiently than narrow-flanged I-beams, allowing architects to design taller buildings with less steel per floor. The Empire State Building, the Chrysler Building, Rockefeller Center, and the majority of the Manhattan Skyline that was erected between 1908 and 1940 were built on Bethlehem's H-beams. The company did not merely supply the steel for the skyscrapers. The company invented the beam that made the skyscrapers structurally feasible. The bridges followed. The Golden Gate Bridge, completed in 1937, used Bethlehem Steel for its structural components. The George Washington Bridge, connecting Manhattan to New Jersey across the Hudson River, used Bethlehem Steel. The Ben Franklin Bridge, across the Delaware River in Philadelphia, used Bethlehem Steel. The Hoover Dam, completed in 1936, used Bethlehem Steel for its penstock pipes and structural elements. The Panama Canal's 110-foot-high lock gates, the same canal whose French-era dredges I covered in an earlier video on this channel, were fabricated at Bethlehem. The company also produced specialized armor plate that was hard as glass on the outside, but flexible on the inside to absorb the impact of incoming shells, a technology that made American battleships among the most heavily protected warships in the world. When World War II began in September 1939, Charles Schwab had just died. Eugene Grace, who had been president of Bethlehem Steel since 1916, was on the company golf course when a caddy hurried across the fairway and told him that Germany had invaded Poland. Grace reportedly looked at his fellow executives, the men who played golf on the company course, and dined in the company dining rooms and lived on Bonus Hill, and said, "Gentlemen, we are going to make a lot of money." His prediction was precise. Within weeks of the United States entering the war after Pearl Harbor, Bethlehem Steel had more than $1.3 billion in orders for ammunition, battleships, aircraft components, bomb casings, and armor plate. The Bethlehem plant ramped production to wartime levels. The company doubled its workforce from 13,055 to 31,523 by 1943. Women entered the plant in significant numbers for the first time, working jobs on the furnace floor and in the rolling mills that had been exclusively male since the plant opened. Bethlehem's shipbuilding division, operating yards at Sparrows Point in Maryland, at Quincy in Massachusetts, at Staten Island in New York, and at San Francisco, produced warships at a rate that exceeded Grace's promise to Roosevelt. The shipyards operated around the clock in 3 shifts. Hulls were laid down, welded, fitted, launched, and delivered to the Navy in weeks, rather than the months that peacetime schedules required. The company became the world's largest supplier of ships, producing more than one a day at its peak, 1,121 warships for the Navy. The armor plate that Bethlehem forged for those ships was a specialized product that no other American company could match in volume. The plate was hardened on the outside to resist incoming shells and engineered to be flexible on the inside to absorb impact energy without shattering. The process for manufacturing this armor was classified during the war. The forging press that produced it was one of the most powerful industrial machines in the Western Hemisphere. The Arsenal of America was not a slogan, it was a production schedule. The men who worked the blast furnaces and the rolling mills and the forging presses at Bethlehem during those years, and during the decades before and after the wars, were drawn from the immigrant communities that had settled in South Bethlehem beginning in the late 1800s. Eastern and Central European immigrants, Hungarians, Slovaks, Poles, Ukrainians, Croatians, Slovenians, and Italians had been recruited by Bethlehem Iron and later by Bethlehem Steel to work the jobs that earlier generations of workers had held, the furnace jobs, the rolling mill jobs, the coke oven jobs, the jobs that required a man to stand in front of molten metal at 2,500 degrees Fahrenheit for 12 hours at a time and then walk home up the hill to the wooden row house where his family was sleeping. These immigrant communities built the ethnic churches that still line the hillsides of South Bethlehem, one church per block in some neighborhoods, each congregation representing a different national origin, each constructed in the architectural style of the old country, each built within walking distance of the plant where the parishioners spent their working lives. The Slovak Catholic Church on one block, the Hungarian Reformed Church on the next, the Ukrainian Orthodox Church on the next, the Italian Catholic Church beyond that. The steeples formed a skyline on the hillside above the plant, and the smokestacks formed a skyline on the valley floor below, and the men who attended the steeples spent their shifts inside the smokestacks, and the distance between the two was a 5-minute walk downhill and a 12-hour shift uphill. The steeples and steel walking tour operated by the Steelworkers Archives and the National Museum of Industrial History traces the route from the churches to the furnaces and back, showing visitors the geography of a company town where the steeple and the smokestacks defined every aspect of daily life. The tour guide points out churches that are no longer active, congregations that dissolved when the plant closed and the families moved away, buildings that have been sold to other organizations or to Lehigh University. The physical infrastructure of the immigrant neighborhood survives. The communities that built it largely do not. The executives lived differently. Prospect Avenue in the hills above the plant was known locally as Bonus Hill. Bethlehem Steel's senior executives, whose compensation was among the highest in American industry, built mansions on the avenue overlooking the furnaces and the river and the immigrant neighborhoods below. Eugene Grace's annual compensation in the 1930s and 1940s made him one of the highest paid executives in the United States. By the mid-1950s, 7 of the nation's 10 highest paid corporate executives worked for Bethlehem Steel. The company maintained executive dining rooms with extravagant meals, the leftovers taken home by the executives for private weekend entertaining. The company's private police force was larger than the city of Bethlehem's police department. The homes on Bonus Hill were maintained with company-paid grounds staff. The distance between Prospect Avenue and the furnace floor was measured in feet. The distance between the compensation at the top and the compensation at the bottom was measured in another unit entirely. The decline began in the 1960s. Japan and Germany, whose steel industries had been destroyed in the war, rebuilt their plants in the 1950s with modern technologies that Bethlehem and the other American producers had not adopted. Basic oxygen furnaces, which could produce a heat of steel in 40 minutes, rather than the 8 to 24 hours required by the open hearth process, were standard in Japan by the early 1960s. Bethlehem continued to rely on open hearth technology. Continuous casting, which eliminated the intermediate step of pouring liquid steel into ingot molds and then reheating and rolling the ingots, was adopted in Europe and Japan, while American producers continued to pour ingots. The mini-mills, small electric arc furnace operations that melted scrap steel rather than smelting ore, began taking market share on structural steel and reinforcing bar, the bread and butter products that Bethlehem had dominated for decades. Foreign imported steel was as much as 20% cheaper than domestic production. The 1959 steel strike, which lasted 116 days and halted 85% of American steel production, accelerated the shift to imports by demonstrating to American buyers that domestic supply was unreliable. Bethlehem Steel reported a loss of $1.5 billion in 1982, the worst single-year loss in the company's history. Plant closures began across the system. Lackawanna shut down. Johnstown contracted. The Bethlehem plant itself began shedding operations in stages through the 1980s and early 1990s. The workforce that had peaked at over 30,000 shrank to thousands, then to hundreds. On November 18, 1995, a Saturday, the workers at the Bethlehem plant fired the blast furnaces and the basic oxygen furnace for the last time. They had been notified earlier that year that the plant was closing. 500 workers remained on the payroll for the final operations. Despite knowing it was the final shift, despite knowing that every man in the plant would be unemployed by Monday, the steelworkers gave full effort. They fired the furnaces. They charged the ore and coke and limestone into the skip hoists. They tapped the iron from the crucible and watched the bright orange river flow across the cast house floor one more time. They poured the steel in the basic oxygen furnace. They rolled the last beams in the rolling mill. They made the last cut on the saw line. Workers and their families gathered outside the plant to watch the last pour from Blast Furnace C. Some of them had worked at the plant for 30 years. Some of their fathers had worked at the plant before them and their grandfathers before that. 3 generations of steelworkers, ending on a Saturday in November in the same furnace complex where John Fritz had lit the first blast furnace 132 years earlier. Inside the plant, when the beam yard saw operator made the final cut, the mill fell silent for the first time in 138 years of continuous operation. The sound of the rolling mill, the sound of the blast furnace blowers, the sound of the cranes and the ladle cars and the ingot molds and the forging presses, sounds that had been continuous 24 hours a day, 7 days a week since January 4th, 1863, stopped. Dave Swartz, the saw operator, described the moment in an interview preserved at the Steelworkers Archives. When the saw operator made the last final cut, the tears started to come down our eyes, and we hugged everybody. We were sad, and that was the first time we heard the mill silent. A lot of the guys you work with, you're never going to see them again. Someone played God Bless America over the plant loudspeakers. The furnaces went cold. The blowers stopped. The ore bridges stopped. The conveyor belt stopped. The men walked out of the gate, and the gate closed behind them, and the plant that had armed 2 world wars and built the New York Skyline and employed 31,000 people at its peak was empty. Bethlehem Steel filed for bankruptcy in 2001. The company was dissolved in 2003. Its remaining assets were acquired by International Steel Group. 146 years of continuous operation, from the Salcona Iron Company's founding in 1857 to the final dissolution in 2003, encompassing the Civil War, the Spanish-American War, both World Wars, the Korean War, the Cold War, the construction of the American Skyline, the bridging of every major river and strait and harbor in the country, the arming of the fleet that controlled the Atlantic and the Pacific, ended in a bankruptcy filing and an asset liquidation. In 1982, the songwriter Billy Joel released a song called Allentown about the steelworkers in the Lehigh Valley, the twin cities of Allentown and Bethlehem, describing lives defined by the demise of the manufacturing industry. The song captured what the workers already knew. The plant was dying. The valley was dying with it. The furnaces remain. 5 blast furnaces on the south bank of the Lehigh River, rusted, silent, their refractory linings crumbling, their piping corroded, their skip hoists frozen, their tuyères sealed, their hearths cold for 31 years. The Hoover Mason trestle runs along the top of the ore conveyor line at the base of the furnace row, and visitors walk the 1,650-foot length of the trestle and look directly into the structures that produced the iron that became the steel, that became the bridges, the buildings, and the battleships. The plaques along the trestle tell the story in fragments. One plaque shows the photograph of the men standing at Furnace C on November 18, 1995. Their faces are visible. Their names are not on the plaque. I started with a question. What did Bethlehem Steel build? The list is the answer, and the list fills the skyline of every major American city and the hull of every American warship that fought in 2 world wars. The furnaces that made the steel for that list are standing in Bethlehem, Pennsylvania, rusted orange against the Lehigh Valley sky, with a concert venue at their base and a casino on their flank and a pedestrian trestle running along their length and a museum inside their shadow. The furnaces are the last physical connection to the company that was called the Arsenal of America, and the men who operated them, the immigrants from South Bethlehem's steepled hillsides who worked the 12-hour shifts on the furnace floor while the executives ate extravagant meals on Bonus Hill, are in the Steelworkers Archives and in the parish records of the ethnic churches and in the memories of the families who stayed in the Lehigh Valley after the plant went silent. The furnaces are still standing. The men are in the archives. The archives are open. There are more of these stories. More machines, more furnaces, more men who went into the dark and came out different or didn't come out at all. Subscribe if you want to see what I pull from the records next. If you want to see the last surviving blast furnaces from Carnegie's Homestead Steelworks standing on the bank of the Monongahela River in Rankin, Pennsylvania, rusting in the same weather, telling the same story, that video is on screen now.